Welcome back to parts 3 and 4 of the fundamentals of the Raspberry Pi. If you don't already know, this 12-part series we will be looking at the fundamentals of programming and wiring and how we can build on that to create cool things in the future. Each of the 12 parts introduces a new idea that we can build on in the future. The first 6 episodes will be on the basics, while the next 6 will be more advanced topics. In addition, we have interesting projects in the middle of the course to test skills that we have just recently learned. In this episode, we will be focusing on the world of Python. However, since this is a relatively short topic, we will be combining parts 3 and 4. So today, we will also be looking at lighting an LED. So let's get started. Before lighting an LED, you might be asking, what is Python and how are we going to use it? Well, put it simply, Python is an object-oriented programming language that we will be using in this course. It was invented in 1989 by Guido van Rossum. The reason why we're using Python is because it's extremely easy to learn and it is only one of 2 languages that are compatible with the Raspberry Pi's GPIO pins. In addition, Python is skyrocketing in popularity, therefore we will probably be using it in the future too. Well, last episode we looked at GPIO pins, also known as general purpose input and output. That will be our main focus while working with Python. Inputs and outputs is all that comprises with coding with GPIO pins. Using specific functions and libraries, we can easily manipulate specific pins on our board. In our case, all we're doing is outputting voltage to an LED. To start off, we'll first need a simple Raspberry Pi. This is the Raspberry Pi 3B+, but as mentioned before in my other videos, it really doesn't matter. After the Raspberry Pi 3, you will also need a breadboard. Breadboards are really common. They are typically used to connect wires with pin sockets, to make the wiring easier. In addition, it also prevents you from soldering too much. In addition to that, we will also need 2 female wires, 2 male wires, and also 2 male-to-male wires. These will be common in our breadboard connections to light our LED respectively. Adding on to that, we will also need a simple LED. Here I am using a yellow LED, but make sure you check which LED you are using. Different LEDs require different voltages, so you could short wire one LED without even trying, so be careful. Before we go programming, we need to wire our circuit together. Luckily, this is pretty simple. First, connect your LED to the breadboard, making sure to remember the long and short wires. After that, connect a pin from ground to the negative side of our breadboard. This is what's known as a bus, which we can transmit ground data to any pin on the negative side of the breadboard. So for example, if we take that negative side and connect a wire to it, we can transmit that ground data to anything else, such as our LED. After this, connect another wire to a random GPIO pin to the longer pin in the LED. This is where we can send voltage to the LED to turn it on. Based on what LED you want to turn on a resistor, but since we have a yellow LED, that won't be necessary. Finally, using the bus we made before, connect a wire from the bus to the shorter wire of the LED. The circuit is now complete, and now we can begin programming it. So first up, when you boot your Raspberry Pi and connect to HDMI, you will be greeted by the Debian desktop. First up, you want to open up your Folders app. With this, you can see all your folders in the Raspberry Pi. When creating a project, it is always a good idea to create a folder for your project. I called this one LED to represent blinking an LED, which will be our first script. Then I'll create a file called led.py. py is the Python extension for a file, so we can edit it with our Python editor. To edit the file we have just created, like we called it LED.py, go to the RPI section and click on Programming. Then click on Thonny Python IDE. Thonny is an integrated development editor, also known as an IDE, that allows us to debug and run our Python files. When Thonny has been opened, click on the Load file in the top right corner. After that, you want to select the directory that we made earlier, and consequently, after that, select the file we made earlier as well. Now we can begin editing that file. First, we need to import some Python packages, or you can call them libraries. So the first one is the time module, and it's built-in so we don't have to do pip. The next one is rpi.gpio module. This module allows us to manipulate GPIO pins on the Raspberry Pi. We then import it as GPIO for short, so we don't have to type rpi.gpio over and over again. We now have all the functions of the rpio.gpio class that we can use freely. The first function that we use is the setMode function. As mentioned in our previous video, we have to set our pin ordering system from BCM or board. In this case, I have selected the board. But you can also select BCM formatting as shown here. The second function that we use is the setup function. We discussed how GPIO stands for General Purpose Input and Output. We need to set the pin as either an input or an output. Since we don't get anything from the LED, and instead we actually send voltage to the LED, we set up the pin as an output. I have chosen pin 40, but you could choose the pin that you've wired up before. If we weren't using an LED, but instead like a sensor, you would consequently set up the pin as an input. But because we are receiving data from the sensor, we don't use that. We have now officially set up the pin. We can now turn on the LED. To do this, we use the gpio.output function. This sends a voltage to the pin that we have set up. For instance, with a 1 value. Since we are sending digital data, 1 means on, while 0 means off in our case. So right here, we are sending voltage to pin 40, and we're setting a high voltage to the thing. So if we sent to 0, it would turn the LED off, but if we turned 1, it would turn the LED on. Right here, I'm adding another line to the turn the LED off with a 0 value. This will turn the LED on and off instantaneously, so we won't exactly be able to see it. This is where the time module that we imported before comes into play. Here, with the time module, we delay the code by 5 seconds so that the LED remains on for 5 seconds but then turns off. We do this with the sleep function, and we turn in an integer. After this, we have to add another line to our program. We call this gpio.cleanup. We do this so that our GPIO pins don't get cluttered with useless information from previous programs. When we run the script, the LED turns on for 5 seconds and then simply just turns off. So this is surprisingly powerful because with just a few lines of code, we were able to turn on and turn off an LED. Let's make a more interesting project by making the LED fade in and out. We do this with a technique called pulse width modulation. With this, we can adjust the voltage being sent from a pin. First, we initialize the pin with the PWM cycle. We do this with the PWM function. Then, we start the cycle with 0 voltage. This can be done with the start command from the PWM object that we just created. We then create a while loop that runs infinitely when the program is running. We then create different for loops that gradually increase the duty cycles. We also create another for loop that gradually decreases the duty cycles. Also, I added some sleep functions to prolong the fading effect even further. PWM, or pulse width modulation, operates on duty cycles, which translates to different wavelengths. In short, higher duty cycles increase the voltage that we send through a pin. With this, we can gradually increase the duty cycles in the while loop, creating a fading effect. As you can see, when we run the script, it fades in the LED and then fades it out. So this is what our script will do with pulse width modulation. This will become useful later on for sensors and different types of sensors. That's all for today. Thank you for watching. See you in the next video.